Hey, welcome back to Mr. Phelps with Precal. This is Unit 4, Topic 3, Lesson number 6. We're going to be writing complex numbers in polar form, or otherwise called trigonometric form, which you see right here. All right, recall that complex numbers, if you remember back in Algebra 2, complex numbers are made up of a combination of a real part. So this is real, and then we also have an imaginary part. A complex number can be represented by points A, B, so that's rectangular form, and graphed on a coordinate plane, just like you see right over here. The complex plane consists of a horizontal axis, which is called the real axis, so that's R, and the vertical axis, which is I, for the imaginary axis. Now, if I'm going to graph an imaginary, or I'm sorry, if I'm going to graph a complex number, complex meaning it has a real part and an imaginary part, so I'm going to use the real part to go along this axis. So that's negative 5, 1, 2, 3, 4, 5. And plus 2i, so that would be 2i's going up. So that would be that point right there. Okay, polar form of trigonometric form. So this is trigonometric form. So z equals a plus bi. So a plus bi, remember, is that complex number. If you're going to write that in trigonometric form, so that's z equals, which is going to be the radius times cosine of the angle plus I times sine of the angle. So that's the way it's going to be written right there, and that's what we call trigonometric form. All right, so we're going to be converting these complex numbers into trigonometric form, and then I'm going to graph it. All right, so radius is equal to the absolute value of z, so that makes sense because that's like the absolute value, which is the distance that it's gone. Of course, it's got to be positive, which is absolute value. And we're going to use the same formula that we used back when we were finding the vectors. So this is how you find so if you have the x and you have the y, then you find the hypotenuse by using this formula, which is basically Pythagorean theorem. And then we're going to use the exact same formula to find the angle as we've been using for rectangulars as well. Write the complex number in polar form. So we have 4 minus, remember, 4 is A and negative 4 is B. So if I'm going to find the radius, so that would be R equals the square root of 4 squared plus negative 4 squared. Now 4 squared is 16 and negative 4 squared is also 16, so this adds up to 32. Square root of 32 is your radius. Now I'm going to do the same thing to find the angle, and I'm looking around for, I'm going to pause, I needed my graphing calculator. All right, to find the angle, I'm going to do inverse tangent of y over x, or in this case, b over a, because b really is the y and a really is the x. So that's negative 4 over positive 4. So I put that in my calculator, inverse tangent to negative 4 divided by positive 4, which is really just inverse tangent of negative 1, which you probably even have memorized. That happens to be negative 45 degrees. Now, negative 45 degrees, remember, is in the fourth quadrant, so if you think of a regular Cartesian graph, and this is 4, negative 4. 4, negative 4 would be in the fourth quadrant. So that is the right answer. We don't have to add 180 to it. Now, I don't like negative angles, so I'm going to find the coterminal. I'm going to add 360 to this, and that's going to give me 315 degrees, which is literally the exact same angle in the exact same position. So I really didn't change it. I just want to change the way it looks. All right, so then I can now write my answer. So z equals, the radius is square root of 32 times cosine of 315. Now you can change 315 degrees into radians if you want. You can divide this basically by 180 and then press math enter. I believe it's like 7 pi over 4. But I'm going to leave it the way it is. So that's plus I times sine of 315 degrees. And there you go. There's the equation that we were looking for. Oh, the graphing. Whoops. So going back, 315 degrees, once again, is 7 pi over 4. 315 degrees, let's see, 180, that's 360, what's that, 45 degrees less than, yeah, 45 degrees less than 360, so that would be like right over here. And then square root of 32 is a little bit more than 5, so that's 4, and so it's somewhere going to be about right there, give or take. All right, example number 2, negative square root of 7. So now you'll notice that we have square roots involved. which I'm not really going to do anything any different. I'm going to do it the exact same way I've done the last question. So first thing I'm going to do is I'm going to find the r, which is going to be square root of a squared. So that's negative square root of 7 squared plus square root of 21 squared. Now, this might look more complicated, but it isn't, because anytime you do square root and square something, then basically they just cancel each other out. And a negative times a negative is also a positive, so really this just becomes 7. And this 21 cancels out to just 21. So then you've got square root of 7 plus 21, which is square root of 28. All right, so now finding the angle. So inverse tangent of y over x, negative square root of 7. I know I say it's really b over a. So I put that into my graphing calculator. So inverse tangent of square root of 21 end parenthesis divided by negative square root of 7 end parenthesis. So we're looking at something that looks like that. Press enter and you get negative 60 degrees. Now, the first thing I need to ask myself is that the right answer, or do I need to add 180? So this is left and this is up. Negative, I don't really care about the signs. So left and up will be in the second quadrant. Negative 60 is not in the second quadrant. So I need to add 180 to that. And that's going to now terminate in the second quadrant at 120 degrees. 120 degrees is, let's see, 60 degrees less than 180. So that's really a 60 degree angle, which would be pi over 3. So this is really 2 pi over 3. So, or 2 pi over 3, it's the exact same thing. So, I'm going to write it out. So, z equals square root of 28 times, this I'm going to use my radians, so that would be cosine of 2 pi over 3 plus I times sine of 2 pi over 3. And there you have it. Okay, one more, example number 3. So we have 3 times the square root of 2 is your A term, and your B term in this case is 3 times square root of 2 as well. Because remember, the order of multiplication really doesn't matter, so this is really the same thing as I times 3 times the square root of 2. So once again, just kind of showing you it's the exact same thing. So this is r equals 3 times the square root of 2 squared plus 3 times the square root of 2, okay, I wrote 2 squared. All right, the square root of 2 and the squareds cancel out to just be 2, and 3 squared makes 9. 9 times 2 is 18. So if this is 18, then this is also 18, which adds up to 36. And the square root of 36 is 6. Okay, so that actually worked out kind of nicely in the end. So we now know r, so the next thing I need to do is find the inverse tangent. Inverse tangent of, well, let's be honest, 3 times the square root of 2 over 3 times the square root of 2, anything over itself is 1. So it's really just inverse tangent of 1, which is 45 degrees. Okay, so the next thing I need to ask myself is this in the right quadrant? So I want it to be right and up. Right and up will be in the first quadrant. 45 degrees is in the first quadrant. So that's exactly the way I want it. Z equals 6 times, I can use pi over 4 if I want. So cosine of pi over 4 plus I times sine of pi over 4. And there you go. You've got your trigonometric form. All right, I'm going to keep it short just to that. Thanks again for watching. Please give it a like if it helped you learn something about writing rectangular form into polar form, which in this case is trigonometric form. All right, thanks again for watching. Have a great day.